What's up, guys? We got another LeetCode problem today. It's day 67 of the 100 days of LeetCode, and it's 2sum2 input array is sorted. Let's do it. So we're given a one indexed array of integers, numbers, that is already sorted in non-decreasing order. Now, all one indexed means is that we are going to start at the index of 1, okay? And that is going to be relevant when we return the indices. Okay, anyway. So it's already sorted in non-decreasing order, and we want to find two numbers such as they add up to a specific target number. And these two numbers can be numbers index 1, numbers index 2, that's what we can call them. And 1 is less than or equal to index 1, less than index 2, less than or equal to numbers dot length. Now, we want to return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array, index 1, index 2 of length 2. Now, the tests are generated such that there's exactly one solution, and you can't use the same element twice. And your solution must use only constant extra space. Okay, so here's an example. Now we have a bunch of different numbers. Target equals 9, of course 2 and 7 sum to 9. So we want to return index 1, which is equal to 1, right? Not 0, because we're using a one index array, and index 2 is equal to 2, and we return a list of 1 and 2. Now here we have another question, and we have 2 and 4, which of course sums to our target 6, so we want to output 1 and 3, because index 0, index 2, plus 1 to each of them, we get 1 and 3, and it explains that there. Now this is another example where we find the sum, and again, index 0, index 1, we add 1 to each of them, 1 and 2. Okay, so we're going to be using a two-pointer solution, and basically what that's going to be like is we're going to start off by having one pointer be at the beginning of the first index of the list. I'm going to use a 0 index array, and then I'm just going to add 1 when we return our solution. So we're going to start with L equals 0, and R equals length of numbers minus 1, right? So we have them on each ends of the list. Now we want to keep iterating while L is less than R, and what we're going to check is we're going to check if numbers L plus numbers R is equal to target. Well, we want to return a list of length 2, right, with L plus 1 because it's a one indexed array and we're starting at 0. And R plus 1, okay? Same logic that I just explained. Now, if that is greater than target, well, since we know it's a sorted array, what we can do is we can just keep decreasing our R pointer, R minus equal to 1, right? So that we get a smaller number on sort of my right side, right? It's on your left if you're looking at this, but basically on the right side of the array, we're just going to keep decreasing that index so we get a smaller and smaller and smaller number. And if the else, which essentially what this else means is if the sum of those two is less than target, well, we can apply sort of the same logic in reverse. We're going to add 1 to L, and we're going to return an empty list. If we find nothing, we won't find nothing, right? Because there's going to be exactly one solution, but you know, I'm just putting that there. And there you go. That's how you solve that problem, a two-pointer solution. If you guys enjoyed that, today's day 67, which means we got another 33 days left to go. Yeah, you know, like, subscribe. We'll see you tomorrow. Take care.